Good morning, good afternoon, good evening, everyone. We have folks joining us literally from all over the world, so thank you for joining our webinar and welcome. Today's topic is Turbocharging FME, or how to improve the performance of your FME workspaces. It's an exciting day today because it's 12/12/12, and the date that is. If anyone's joining us from, I think, the east coast of Canada, the Maritime time zone, you'll experience 12/12/12 and then 12/12/12 during this webinar. So that's great. Today's webinar is a little bit more technical than usual, so we expect that the majority of attendees have probably some FME experience, although you're certainly welcome if not. Okay. So some quick introductions. I'm your host today. My name's Ken Bragg. I'm the European Services Manager for Safe Software. What I'll be doing while our panelists are talking is fielding questions, so by all means, please feel free to type questions into the little questions box in the GoToWebinar panel. I'll try to answer your questions as they come in. If there's some I can't answer, I don't get to, we'll definitely follow up by email. So, introducing our panel. Today we have a panel of 3 experts helping us on this topic. Our first panelist is Mark Ireland, well known as the FME Evangelist, coming to us from sunny Manitoba. Mark, how's the weather out in Manitoba today?
It is snowy, about -15, -17, something like that. But I'm inside, I don't care. So.
Okay, our second panelist, we're lucky to have David Eagle joining us from One Spatial Group. And I have to thank David. It was David that's really been pushing us at SAFE to face this topic a little bit more head-on with our users, the question of performance. So thanks, Dave, for encouraging us to do this webinar. Dave's joining us from the United Kingdom. How's the weather where you are, Dave?
Oh, not as cold as Manitoba, but sort of -4. So yeah, not too bad over here.
Great. And last but not least, Dale Lutz, one of the founders of Safe Software, is joining us today. And Dale's actually out in Vancouver at Safe HQ. How are you doing today, Dale?
Well, really, I'm actually at my house in Langley. But, I was worried, Ken, because I thought that said Dale Lutz the Flounder, and I was worried about that. But no, it's wonderful here. The skies are overcast, and probably it's the warmest for me than everybody that's online here, so I'm pretty happy.
Great.
What about where you are, Ken?
Where I am, it's a nice sunny day, snow on the ground, a nice cold winter day, so it's really great. Yeah, so just a quick bit of background about Safe Software. Safe Software, we're the makers of FME and some other tools you might know, such as the Esri Data Interoperability Extension. We're about 100 exuberant employees. I think everyone's a little bit more exuberant this week, following on the Safe Christmas party, which was last Saturday. Our headquarters, as I mentioned, are in Surrey, British Columbia, which is just outside of Vancouver, BC. Just a quick note about FME, and I think most of you are probably aware of what FME is, so I'll just do this very quickly. FME is a very powerful tool, really we could say a platform now, for transforming and translating spatial data. We can translate almost 300 data formats now, and we provide numerous tools for transforming the data into the exact model and structure that you want to deal with. FME workflows are authored in FME Workbench. This is our graphical tool for authoring workspaces, and most of what the panelists are going to be showing today will be based around FME Workbench. So you'll see in FME Workbench here, we author transformations. On the left-hand side, generally those little brown boxes represent layers of data that we're reading. The blue boxes are transformers in FME. There's literally hundreds of transformers for doing transformations to data. And then on the right-hand side of a workspace, that's where we represent the layers or the tables or the feature types of information that we're writing. So everything today will probably be focused on FME Workbench, where we author translations. So on to the topic at hand. We know it's safe that many of you are now using FME to move vast sets of data. And that's great news for us because we think FME is a fantastic tool for doing this. but it does mean that you expect a lot from us when it comes to performance. And we take this challenge very seriously at SAFE. So our promise to you is that FME is faster than a helicopter. No, really our promise is that that with each release of FME, we try to make everything that we do faster and faster. So what that means to us, not so much talking about how long it takes to start up Workbench, but we're talking about the actual data processing time. So we run literally thousands of tests with every build of FME. If we see that something has become slower, we will generally roll that change back and try to make that thing, whatever it is, that reader, that writer, that transformer, faster than it was before. So we go to immense efforts to try to meet this challenge, to try to be as performant as we can. But we know that despite all of our efforts, all of you have some workspaces that take a very long time. And that's what we're talking about today. So our panelists here are hoping to help you turbocharge your workspaces. And by that we mean make your workspaces run as fast as possible given the tools that we already have in FME. So hopefully we can take your FME workspaces and boost them up to run as quickly as they possibly can. So on that note, before we get started with our panelists, we want to get an idea how long some of your workspaces take right now. Now, I joined David Eagle at an FME World Tour event in London where he asked this question, and I was shocked, really shocked at how long some workspaces take. So I'm going to just start this poll here. So everyone should see the poll now, and what we'd like you to do is just check off how long your FME workspaces take so we get an idea of how serious this performance issue really is, how big of a challenge it really is. So we're getting some good results coming in now. About a third of you have voted, so please feel free to vote. And I'll close
vote early
off
and vote often.
Vote early and vote often. I think it's a multi-choice actually, so yeah, the vote often is true. So just a couple more seconds. If everyone that has an opinion on this, please go ahead and vote. And I will close the poll. And okay, so, and I think I can share the poll results here. So it looks like yeah, over half of you have workspaces that take more than 4 hours. There's a significant amount of people who have workspaces that take even more than 2 days. So clearly this is a challenge for us, and that's what we want to deal with in this webinar.
Wow.
So on that note, I'm going to hand things over to our first panelist. So Mark Ireland, I'll make you the presenter here.
Okay, thank you.
And
we need to...
Or do I need to hide the poll, or?
I already did it.
There we go. Thanks.
What are we seeing? Can you see my screen now?
Yeah.
We've got you.
Fantastic. Okay, so what I'm going to talk about today is obviously workspace performance, and if it's not being too obvious, the key to workspace performance is trying to reduce the amount of data that you're handling. And obviously, I don't mean what your source data is, I mean the amount that we're passing through FME and how we process it. One of the things, maybe this is a concept we just need to cover first, about feature and group transformers, and this is going to be important for what Dale's talking about later, I think. So, and some of our transformers work on one feature at a time, others work on a whole group of features at a time, and it's the group transformers that really make a hit on performance, and we need to do something about to try and improve that. And then just to try and prove that, say we wanted to measure the height of all of these people that we've got on screen, well, that would be a feature-based process. We can take each person or each feature one at a time, and we can move them into our measuring facility, measure their height, and send them on their way. And we can keep doing that with all of these other people, one person at a time, measure their height, send them out. So this is what we call a feature-based process. And the important thing here is it's only ever one person at a time being processed, or one feature at a time. And so feature-based transformers work on one feature, and they're less resource intensive. On the other hand, group-based is a bit different. So for example, say I want to measure the average height of all of these people. or a group of these people, say all of the guys in here, well, obviously I've got to measure them all at once. I can't measure the average height one person at a time. I need to get them all together to manage the average. And so that's what we've got here. We've all of these people being processed at once, and we've figured out the average. But we needed to get all of that group in memory all at the same time to process them. So group-based transformers, they work on many features at a time, and they're more resource intensive. So that's one of the things that we have to look at and try and figure out what to do about it. Now, what do I mean by a group-based transformer? Well, let's just have a quick look at an example. Basically, any transformer that you open up that has a group-by setting, you'll know it's a group-based transformer. And so what does that group-by setting do? Well, that defines what our groups are going to be. So we could, taking that example, we could say group by gender to have the men and the women measured separately. We could also group by clothing color and sorts of things like that. Or in spatial data terms, we could group by an ID number or a flag or something like that in this case. And that will create a whole bunch of groups being processed. And if you don't set a group in here, well, don't think that there's no grouping going on. All that means is every single feature is forming a group now. So this area builder is a good example of a group-based transformer because obviously you need to have all of your line features together to create polygon features, and you need to have them as a group. So what can we do about groups? So if you've got to use a group-based transformer, then you've got to use it. So what can we do with some of them to improve their performance? Well, some of them actually have parameters in there that will help us do that. The clipper is the classic example, which I'm going to show in a minute. These are just the ones I can remember offhand. There might be more than this. But what these settings do is try and turn them from being group-based into feature-based, if you like. And let's have a look at an example of that with the clipper in FME Workbench. And so I'm using FME 2013 just out of interest, in case you've noticed a little bit difference. So what I've got here, I've got some source data that's a bunch of zip codes or postal codes, and also got addresses as well. And I'm trying to find all of the different addresses, basically trying to find out which address falls inside which zip code, and I'm using the clipper to do that. There's a number of transformers I could use. I could use the spatial filter or the point and area overlayer, but in this case I'm going to use the clipper. That will work just as well. The cloner is in there, by the way, just to pump up the amount of data that's coming through the addresses, because what I want to do is make it run long enough that it's going to show you something useful, but not too long that we're sitting here all morning waiting for it. So what's this setting in the clipper that we've got? Well, at the moment it's called clipper type, and at the moment it's set to multiple clippers. And the reason for that is I've got multiple zip code boundaries coming in for each, for the addresses to be clipped against. So I'm going to run that translation, and it should take about 5 seconds. So there we go. 5.5 seconds. This is session duration. And the other indicator in the log that we're interested in is this peak process memory, which peaked at 202,000 kilobytes. So that was the maximum memory that we used. So you can tell at that point, that's when we had everything stored in memory to process it. So let's go back to that setting. Apart from multiple clippers, we have this option called clippers first. So what's the difference with that? Well, with multiple clippers, we're saying to the clipper transformer, take all of our data, hold it in memory, wait till you've got everything, then start clipping that data. But with the clippers first, what we're doing, we're saying, okay, the first features to come through are going to be clippers. So subsequently, any addresses that come through to be clipped, they don't need to be stored in memory because we've got all the clip boundaries ready. We can just pass the addresses straight through. So each address, really we've turned it into feature-based now. Each address comes through and gets processed separately. So let's run that. And the numbers were, remember, 5.5 seconds and 200,000 kilobytes. And I don't think it's going to run a great deal faster, but we should find a lot less memory. So yeah, so the time to process was the same in this case, but the memory usage, 73,000. So we basically cut out 60 to 70% of the memory use in our workspace because of this. And okay, that might not make a lot of difference in this example, but I've just got an example that will fit in the time frame I've got. If you've got a workspace that's running for 2 days clipping data, and you can chop off 60% of the memory use by doing that, and it's well worth doing. And obviously at some point we get so much data in memory that we're having to cache the disk, and that slows it down even more. So at some point having too much data in memory will slow the workspace down. So this is why we try and improve the memory usage and the as well as the time it's being used.
For
So
long-run processes, this is a really significant point. So
it is, yeah. That's right, David. If you can chop off that amount of memory usage over 2 days, then that's going to make a difference. And Neighbor Finder has got a similar thing. It's got a candidates first option, so you can do the same thing with Neighbor Finder. And we try and do that with all sorts of different transformers that we can, to put some sort of parameter in there to help out with that. Okay, so that was transformers. Oh, sorry, going back to that, one of the questions might be, well, how do we know that the clippers are going to be first into this data set, into this transformer? Well, the reason we know that is because we can order the readers in the navigator window, and as long as my zip code boundaries are at the top of the list, then I know they're going to get read first. And so basically I can say clippers first, and I can confirm that's going to be the case. And I can change that by dragging one data set or one reader above another. That's new for 2013. Before you used to right click and say move up and down, but now you can drag them up and down. And so as long as my zip code boundaries are at the top, I know they're going to get read first, and therefore I can confidently say to the clipper these are going to be first. If that wasn't the case and I run them and they came second, well, I get no output because the log file says no clippers supplied, all clippies are outside. And that's because they didn't turn up first, so we'd assume there weren't any. So that's one thing you need to be aware of in that case. Well, what reminded me of that was this next hint I've got, which is the ordering the writers. So we ordered the readers there, but you can also order the writers in the list. And I wrote an article about this on the FME Evangelist. So if you go to fmeevangelist.com, and if you don't remember this number, just search for airport, because I compared the process to an airport waiting room, and I'll show you a demonstration of this just to show what I'm talking about there. So here I'm reading and writing the same data. I'm reading them out to 2 different formats. I'm writing the zip codes out to shape and the addresses out to GML. So I'm just going to run that translation here. And so this tip works when we have multiple writers in the workspace, and you can see the log perhaps says multi-writer writing features. So again, that took 7.6 seconds, and memory usage was about 200,000 kilobytes. And what's happening there is that when FME writes data to 2 or more writers, it's caching the data right at the very end before it writes it out. So what we can do there, we can make sure that the writer that's getting the most data is actually at the top of the list and being written first. And that way we're clearing the bigger amount of data out of the cache faster and using less memory. So again, I can do that by making sure the one writer is above the other. Now, which writer here has got more data going to it? Well, it seems fairly obvious it's going to be the address writer, because it's got 36,000 features compared to 8 zip code boundaries. So really I should make sure the address is above in the output. So I just dragged it above in the output. Remember, it took 7.6 seconds and over 200,000 kilobytes. So this time we run it 7,000 kilobytes. So we've basically chopped off about 10% of the time and 25% of the memory usage just by moving one writer above the other, like a 2-second change. So again, if you've got a 2-day process that you can chop 10% of the time off 25% of the memory, then that's really going to have an effect. Even with a 4-hour workspace, I think that's going to be quite useful to do. It's going to save you a significant time. So yeah, that's just moving one writer above the other within the navigator. So the basic rule there is pick which writer's got the most data and make sure it goes to the top of that list. And well, which one here has got the most data? Well, it seems obvious that it's the one with the most features. Not necessarily the case. Really, you've got to take into account the amount of data as well, the amount of vertices. So although there were 36,000 addresses, they are only point features, whereas the zip code boundary is only 8. But they're quite complex polygon boundaries. So maybe the gain in time there wasn't that huge because the difference in the sizes of data isn't that big. But obviously the bigger the difference in the two data set sizes, the bigger the performance improvement you're going to get by moving that data to the top. And one last set of tips here, attribute handling. Basically remove any unwanted attributes from your workspace, and again it will save memory and save time. Again, beware of large lists, and I'm going to show you something in a moment to show you what that will be a problem with. And don't store geometry as an attribute. Sometimes you have to do that, but try and drop it again as quick as you can. Don't read a database, a spatial database using a non-spatial reader. If you're going to read the geometry column into an attribute, that would be bad. So let's have a look at that. An example here. Basically, I've got this address data. It's got a whole bunch of attributes on there, and I'm using the attribute remover transformer to get rid of many of those that I can that I don't need. And by removing them, I'm reducing the amount of memory used in this workspace and making it more resource friendly. And the point and area overlay, I just wanted to show that I've got a list in there. I've called it address list. Well, maybe I didn't know what the list name does and I just type something in for the sake of it. That would be a bad idea, because now what I'm going to get when I run this translation is I'm going to get a list of addresses for every zip code, and if I query one of these zip codes, what we'll find is that I've managed to add 14,000 attributes onto that data by merging 1,000 features with 13 attributes each, and that's given me nearly 13 or 14,000 different attributes on there that I probably didn't really need. So just beware of lists. Don't use a list if you don't need to use it. Just let's leave that blank. It's not a compulsory field. Let's not carry 13,000 attributes through there. I don't need that information. And so yeah, that's just a few tips for speeding things up, reducing memory usage as well. Remember to look in the log right down at the bottom at the peak process memory. That'll tell you what the peak was. And remember, if you get above what your system's got, we're going to start caching things to disk, which will slow it down. So the more you can reduce that memory, the faster you will make your translations. So great. I think that's me done. So I'll hand you back to Ken.
Thank you very much, Mark. That's really great stuff. Let's see now, showing the right screen. Yeah, so that's great. Before we jump over to Dave, I just want to run another poll. And the question we have now is really, where does it hurt? Or to put it another way, where do you think your performance pain is coming from? So I'm going to launch that poll. Just have a look at the possible answers here. We want to get an idea where folks think that most of their performance problems are coming from, whether it be geometry-related stuff, database joins, database reading, writing, or sometimes just the time it takes to write big files to disk can be the bottleneck in the process. So sometimes it's hard to tell, granted, and I think Mark gave some good tips there about the log file, but if you can sort of have a guess at where you think your performance pain is coming from, we'd appreciate knowing. So I'll close this poll off shortly. We're on a tight schedule, so please answer the poll in the next few seconds if you haven't already. I'm going to close the poll now. We had good response there, and I'll just show our results. So it looks like 44% geometry processing. So geometry is a big one, but the other three, database joins, database reading, writing, and writing big files, are all significant as well. But that is interesting. We've done a lot of work there, and Dale's going to be talking about some of the geometry stuff that we've done around multiprocessing when we get to Dale's time at the end. But now we're going to hand things over to Mr. Eagle, who's going to talk about working with databases. And I don't know if I mentioned at the beginning, but all of our panelists have nicknames. So we had iMark there, Dave we can refer to as the Eagle. And we'll hand it over to Dave. Let's just pass you on there. There you go.
So can we say the eagle has landed now?
The Eagle has landed. That's great.
So there we go. Now he's landed. I'm going to focus on working with databases, and the interesting poll questions and the results there, sort of focusing the second items there, most significant were on database joining and reading and writing databases, and they're two of the things I'm going to focus my attention on here. I mean, really, one of the things...
Sorry, Dave, we don't see your screen yet, or at least I don't.
Okay.
No, I don't either.
You're the presenter, but I think you just need to share your screen.
Yeah, it has... see if we've got that now.
That's it.
Yep,
Okay.
there we go, thank you.
It just didn't kick in at the last second. There we go. Okay, so we're really going to focus on trying to be a speed reader wherever you can. Actually, when you're working with a database, typically you're working with a significant volume of data. So trying to read that data as intelligently as possible means that you can try to be as efficient as you possibly can. Certainly, if you come to working with databases fresh, then your typical approach to building a workspace in FME might be very similar to how you have worked with file and folder-based data sets. So very similar to the demonstration that Mark highlighted, this is a workflow that carries out some clipping, and the important thing here is that you make sure you adapt the order of your readers so that in this case, I'm reading some municipal boundaries. These are county boundaries, so you can see that if I view those in the viewer, you can see that data there. And just to give you a little bit of context, some of you will probably be aware that you can drag in data into the viewer, so I can put a TIFF into the view to see the background data behind the raster data behind the vector there. And I'm using a tester to guarantee that I'm reading the data in. I'm using the tester to fish out the Cambridge boundary for my workflow. And then my other reader is an Oracle database. So I've got a local instance of Oracle, and I'm going to read in all the data from that database table. There's sites of special scientific interest. And we had a question while Mark was talking about getting rid of attributes, and my sort of statement whenever I'm talking to anybody about working with FME is that if you're not going to use it, then lose it as soon as possible. So if you have a significant number of transformers in your workflow, at the point that you can get rid of attributes or you can downgrade geometry, then do so. For example, it's quite common that you might want to work with a center point of a polygon. Well, don't carry the polygon all the way through to the end and then extract its center point. Coerce the geometry as soon as you can. Here you can see that the viewer has popped up, giving us the results of that clip. And essentially, if we go and inspect the log, just as Mark was doing, you can see that here we've got a sort of a sub 30-second run processing, but reading all of the data from that SSI data set, so nearly 9,000 sites of special scientific interest there. So what the key thing to this workflow is to start to become an FME hero and work with parameters. Parameters in FME really allow you to have superb granular control over what you're doing with your workflow. And as a desktop user, prompt and run allows you to initiate and send a parameter at runtime. And certainly if you're an FME server user, then you'll be very familiar with parameters because they're integral to how your workspaces run in the server environment. The key thing, though, really is to try and get the database to do the heavy lifting where possible. The database is generally optimized to do some of this heavy joining and spatial relationships. And if we can get that work carried out on the database where possible, then it's more efficient. I'm going to show you a few ways that we can use a handful of different parameters, in this case to issue a where clause to the database, and also to work with the different tables that are in the database. We will really embrace the spatial index when it comes to databases. If you go and have a look at what a spatial index is, a number of databases, spatial databases support those. They're a way of optimizing your spatial query, so you don't have to read absolutely everything in your database table. You can go and pluck out just the geography or the area of interest that you want to work with and read that part of the data into your workflow. So reading within your area of interest, an interesting fact is that since FME 2011, every reader has had the ability to read a bounding area with the format readers. The one thing to note, though, is that whilst every reader allows that, not all formats have a true spatial index, and therefore you are getting some benefit in that what you're doing is reading only the data that you're interested in into the workflow, and therefore that is in memory, and a smaller amount of data will be in memory. When you move to working with a spatial database, though, a true spatial index really does give you a significant benefit, because the read time is so much faster. Now, of course, you can use your usual DBA tool. I've got SQL Developer on my machine that I will use when I'm working with Oracle. But of course, if you're loading the data directly into the database with FME, whatever it is, most of the writers have the ability to generate the spatial index after the data is loaded. So if we dive over to Workbench and take a look at a variation on that initial workbench, you can see it looks very similar, but what I'm going to focus on are the parameters that we have on the Oracle reader. You can see that I have some bounding information here that we're going to pull in, and if I prompt and run, these are published parameters, and I'll show you how we can do that in a second. What I'll do is specify the area that I'm interested in reading from, and that will just give me a very small clip region to work with, essentially. So we pull the upper right-hand corner of the bounding box, and we've got an option here to click to search envelope. Now, if we say no to this, it will essentially be an intersection. We'll get the data back that intersects with the bounding box. If we choose a yes, we'll do a hard clip of the geometry. If we run this now, we were trying to beat about 28 seconds on the previous runtime, and the theory is that this is now going to read the geometry from the database table, and we've now nearly cut that by 2/3 to read just the area of interest. Essentially, we read out the Cambridge area, and then we hard clipped it to the specific boundary of interest there. You can also take that one step further. We have a where clause on the reader as well, and this again, and if we create that as a user parameter, it then is available to us on the prompt and run option. So we could query here where a particular attribute is specific to a certain value. It's quite common that you have a type or a classification field that you would run a query against. So you might do a string query and say where type is equal to high, medium, or low, and just bring those values back. In this case, it's an integer that I'm looking at, a physical area, and we're going to run that query. It issues the where clause to the database, reads the data in the bounding box, but only where the area in hectares is greater than 50 hectares. And now you can see that we've knocked another second or so off that workflow. All the time, sort of chewing down the time that you're taking to read and consume the data. And the case is, as soon as they're published, they're available for you to dynamically set. And speaking of dynamic, one of the other very useful capabilities that not everybody spots, but when I discovered this a few years ago, it makes a significant difference to the speed in which you're processing your data, especially when you're doing testing, when you're building your workflow to begin with. And that's the feature types to read parameter. Essentially what this allows us to do is pick different layers or tables from our database that we want to read. What you'll notice is that in conjunction with dynamic capability, so that's a keyword to search on FMEpedia for, a resource that I'm sure Ken will remind us of at the end. If we determine a dynamic property on the target, it means that whatever schema is read will get written. And that really allows the feature types to read parameter to come into its own, because at the moment if I double click it, it's sort of hard coded to allow me to only read the one table from the database. If, however, I dive into the reader and merge the source feature type, that makes the feature types to read parameter much more dynamic, because it goes and hits the database at runtime and tells me right now what database tables are available to me to process. Now, the beauty of working in a database environment is that these are multi-editing environments with lots of different people contributing to the database. So you could, every time you open this workspace, essentially process a completely different database table if you required. Here I'm going to read in the monument data from the monument tables. These are scheduled monuments in the UK, and if I just run that through, it'll carry out the same process. And this time you can see that we have few large scheduled monuments, but if we click on this one up in the northern part of the county, we can see that if we go and inspect the feature in a little bit of detail, we've got a Roman walled town and hill forts there that we've pulled out of the workflow. So we're trying to be as rapid as we can, but also as flexible as we can, and really just removing any features that we don't need in our workflow on read before we even get them into the workspace itself. So using a where clause and working with SQL is sometimes new to people coming fresh to databases. A particularly useful resource that I've found is the w3schools.com website, and a number of beginners resources for writing good SQL code on there. Really, just a reminder of that feature types to read capability. It really allows you to always see what's new in your database. So a couple of tips on that front. When it comes to working with transformers in FME, there are all sorts of different types of transformer that are out there, not least a grouping of transformers that are sometimes affectionately referred to as synchronous reading and writing transformers. They basically allow you to read data partway through a process, sometimes triggered by an input feature. So you don't always have to rely on a specific reader or a specific writer. And certainly when you're coming at FME as a database person, you may want to query the database in the way that you've been used to by writing some SQL code. And transformers like the SQL Creator and the SQL Executor are very useful for that. When it comes to working with raster data, the raster reader is incredibly useful when you want to build a file path and specifically pick out a raster image from a particular folder and only read that one for your particular workflow. So all sorts of transformers to take a look at in this classification. I'll open up and view a few of those so you can see what I mean. The SQL Creator here at the top, there's 3 small demos in this one workspace. The SQL Creator allows me to write a query that hits my database. So I'll choose an Oracle Spatial database, and you'll notice that the parameters are automatically getting filled in for me because I've set that as my favorite, my default database in this case. And I can write a SQL statement, and this is very useful because I've got a dynamic table picker that allows me to go and query all of the columns from the SSI, Sites of Special Scientific Interest table. But much more importantly, I can be more specific. I don't necessarily want to bring everything in, so I'm going to choose to make sure I bring back the geometry. And if you don't want to type, then you can pick. So I'll bring back the area column and drop that into the workflow. Let me just do that. There we go. And we'll also have the SSI name, which we'll bring in as well. Just sort out my syntax a little bit. Pulling those both from the admin table, and I drop into here my where clause, so where area It is spelling sensitive, that's for sure. So area greater than 1,000. And now we can populate the attributes that we want from the query. So these will be the attributes that get exposed. So it's going to hopefully pull those back for me. And that's there we go. Got that. And then you can see that they're now available. So if I run this workspace now, it will literally hit the database with that SQL query and pull back only what that query returns. No reader in sight in this case, and a very useful little process to bring back those larger sites of special scientific interest from that workflow. So if we just move on a little bit, so I'm going to disable all objects in the bookmark and move down to the next part of this workflow here, looking specifically at the feature reader in this case. And we'll just make sure that our input data set is enabled. This is a SQLite database. I'm reading in my counties again here and testing this time for a different area. We're going to grab the Greater London Authority area. And the feature reader receives that feature and uses it as a trigger, as an initiation to go and pull some data from a SQLite database. And I'm picking data from the monument table in this case. And I'm querying specifically from the feature type that I've just defined, but you can specify different ones here as well. You can also see that my where clause is available for me to use that as well. And then we can select features, in this case, that intersect the bounding box of the initiator. However, it can be more interesting if you're actually working with some of the spatial predicates that are supported. And the ones that are listed in the transformer here are generic ones that you're able to use on any database, but if a particular spatial predicate is supported natively by your particular format, then it is more efficient to use that one. So you will see them in this list prefixed with the format name that you're working with at the time. So in this case, we're going to bring back the result attributes and geometry and return those. So we'll read the data, the feature will initiate the query and bring back only the features that interact with that. So again, the feature reader, very useful. There's my initiator feature, and there's essentially a bounding box that represents all of the data that has been returned on from that monuments table in the SQLite database. Down at the bottom here is the SQL executor, which I'm not going to focus on, but I'm going to mention because that is a particularly useful transformer that works in a very similar way to the feature reader. But it does allow you to work with some of those spatial predicates that your process, your particular format supports. So you'll see the configuration is very similar to the feature reader. We have an initiator feature. We add a little bit of a query into that workflow, and it allows you to go and to bring back any of the data that you're interested in. One of the links here, if you take a look at FMEpedia, so if I just bring that through, there is an FMEpedia article on this topic that's very useful, and the title of it is how to use native spatial database SQL commands to perform spatial queries. So a nice snappy title, but it's a very useful article to read up on over on FMEpedia. Just to finish off then, really, on the database front, one thing that I haven't mentioned is that you can also, of course, go and speak to your friendly DBA. Working with a database means you've probably got a database assistant or colleague that manages that environment. And actually, if you can get that person to create you a view of your data, then a view is essentially a virtual table that's derived from a stored query. And every time you run your process, you create that query and get back the data dynamically. And all sorts of joins and attributes can be pulled back in a view. And if you can get that work done on the database, it's optimized to do it, and it can make your workspaces simpler, but also more performant because you're getting what you need. The extra part of that is that on some of the more corporate database environments, materialized views are also available. And that's where the query itself is actually stored on disk, and it's updated at a frequency that you decide on by some sort of database trigger. And that, because the data is actually stored on disk, the results coming back on, it's significantly quicker again, so worth considering. Just to complete my section then, looking at database joins, databases, when you want to join your geometry or your non-spatial features that you have passing through your workflow to a database or to any environment, really, a number of transformers to take a look at. The joiner versus the feature merger. There's a great Evangelist blog, article 79, which I'd recommend you take a look at, comparing the two transformers and some of the sister and brother transformers to the joiner and feature merger, and how you might make use of those. There's also a transformer that I've made a good bit of use of. It's the inline querier, and it's a particular favorite of mine because it actually allows you to cache your data to disk mid-process, which allows you to pull data out of memory, and that's sort of a byproduct of this of its intended use. Really, the main part of the process of this use of this transformer is that under the bonnet it has a SQLite database, and midway through your process you can take non-database formats and put them into a database environment and then write standard SQL against that data. So it's a very interesting transformer. But at that point, I think my time is up, so I'm going to hand the baton over to Dale. So thank you all very much.
Thanks a lot, Dave. That's great stuff, and clearly this is a topic we need to come back to in future webinars. Probably include some points on performance in all of our webinars going forward. So I'll hand it over to you, Dale.
Okay, green. And we should see, this isn't quite how I look this morning. My kids are a little bit past this age. But I wanted to just kind of kick us off thinking about the concept of doing many things at once. And this gentleman certainly is doing that. The interesting thing when the poll question came up was how many of you are grinding serious geometric processing. And the multiprocessing capabilities in FME, I think, can definitely play a key role in reducing the time it takes to do those sorts of things. So just to kind of introduce it, multiprocessing is the idea that you're going to use more than one of your CPUs to do something. And in the old days when we started, we were lucky to have even one CPU in a computer. Today, even your wimpiest MacBook Air consumer-grade computer will have at least 4. So a desktop's often 8 to 16. So it seems a shame not to make use of them. And so we do have some threading in FME, but for the most data through in a shorter time. And to give you a bit of an idea of the kind of benefits you get, and the key thing that I do not have a slide to say, but whenever you're thinking about using multiprocessing, there's a trade-off. Just like almost everything that you do with FME, there are pluses and minuses that you have to keep in mind. And so really, a great FME user is as much an artist as a scientist, perhaps. But the multiprocessing trade-off is this. To use multiprocessing, we have to send data to different processes. There's a transport cost to moving the data. Once we get it moved, now we're going to do the processing. For multiprocessing to really give you a benefit, the amount of effort in the processing has to greatly exceed the amount of effort to transport the data around. So we shouldn't do multiprocessing so we can do a scale of the data or an offset, because that's just too little work in comparison to the effort of moving the data around. On the other hand, if we're doing 3D clipping of point clouds, that's a lot of work for each point to figure out if it's in a certain cube or something like that. Or buffering is a great example. Dissolving is another fantastic example as well, where the amount of CPU we're doing on each object is great compared to the time it takes to send it around. Many raster operations also fit into that category. So how do we turn it on? Well, there's a setting on transformers, on many of them, that lets you turn on parallel processing. And how does it work? Well, you have to specify a group. And so basically, for each group in the group by, we will then spin up a different process to handle those groups independently, and that's basically the concept. Now we give you some colloquially named terms about how much or how little you'd like to do parallel processing, and you might ask, well, why would you have these settings? In some cases, the amount of work you're going to do in each process is so large and requires so much memory that you don't want these processes fighting each other. So this is where minimal or moderate may be in order. So in other words, the amount of memory that each thing is going to take is actually very large, and so we don't want, since the computer may have finite amounts of memory, we don't want to be bumping into each other. On the other hand, you may be doing things that do not require much memory, and one example is I want to do a bunch of web service calls where each process is going to make 3,000 web service calls, but mostly we're just waiting on the network. So in that case, we might as well go for extreme and have many of these hitting the network at once, and we should get done quicker. One other thing to really keep in mind is that any custom transformer you make can be invoked as in parallel processing. So in other words, if you know that you're going to do a dissolve and then an area calculation and then a sort to pick out the largest thing, that would be great to put all those three things into one custom transformer and then parallel process on that. In general, because again the cost is in sending the data, you want to do as much work once you've sent the data. So if you have a stream of things that are independent that can work on a chunk of data independent from any others, string those together, do as much as you can, do that all separately, and then when you are done, bring it back together, and you'll have a good result. Now, again, on these levels, we tried to make up these names, but here's how they really translate into reality. There's two things, and kind of like the NHL, we have a salary cap or a process cap based on your license level, but we never go on strike. We always do our job.
Dale, I don't know if everyone's going to get that reference.
Well, there's going to be at least 3 or 4 Canadians who are bitter that way. NHL is on strike, so all the people in North America can do is play with FME in the off hours to entertain themselves. But anyway, there is a cap. If you have a base level license, the most we're going to let you do is 4 processes. Professional is 8, and everything else will let you do 16. And Mark Ireland did ask me a tough question, and I did not get the answer. If you use the Workspace runner, we do let you get all the way to 32, and I guess we say, you know what, if you're using the Workspace runner, good on you. You can do 16 more. I don't know why that is the case, and I will look into that. But
I'd like a little image there, the levels that are parallel.
Yes, exactly. I wonder who made that image, Mark. I wonder who it was. Yes, it was Mark Ireland himself. But it is very, I didn't actually notice that those were levels, to tell you the truth, until right now. I thought they were chips before, but yes, they are levels.
Levels of parallel.
That's right, parallel levels. So anyway, if you set it to no parallelism, of course we do just 1, and then it's a function of the number of cores. So extreme will say if you have a 4-core machine, we'll go double that, and that would give us 8. So we would not hit the salary cap if we were a professional. So that's how that math is done. So just in summary, before we look at an example, and I know we are getting dangerously close to 12, 12, 12, 12 in the East Coast, so we want to stop well before that. The main thing I'd like to point out is a great article that Mark did, the Evangelist 94. And Ken, you are going to make these slides available afterwards, right?
Yeah, slides and workspaces will be on safe.com. The link's on the last slide. Yeah.
So that's great. So you can look at that later. And also, Dimitri did a really good write-up on FMEpedia, which with luck I will flip to here. And he goes through a number of different scenarios looking at the impact that parallel processing can have. So making DEMs, and you can see, here's some of the examples. And again, we're doing this with smaller data volumes. Those of you with very large data volumes will see even more dramatic savings. If we're cutting it in half here, that's 30 seconds, but that's no big deal. But if it's in half and it's 2 days, I can make a Scotty reference. If it goes by the book, days get turned into hours, and then that would be very good. Here's an interesting example where you actually change something, and those of you that know about the Google technique of map reduce, where you throw out a bunch of work to be done, and then you bring it all back together and you do a little bit last bit of work to reduce those answers to 1. In this case, Dimitri made a tin for every input LiDAR thing, and then he gets those were done in parallel, and then the results he brings back and makes into just 1 tin at the end. And if I have time, I'll try to make up a dissolve example that would be like that. Dissolve a bunch of pieces into bigger pieces and then gather them together and do the final dissolve here. That's a typical type of technique, and you can see this thing goes from 5 minutes down to 30 seconds, and that does give us those Scotty type answers that we're looking for. So in my last couple minutes, I'll just look at this example where I won't run this one because it takes 1:36. What we do is we are doing the shortest path from, this is a network of the Vancouver streets, and we're reading 500 of our properties, adding the location of the Vancouver General Hospital. So we've got a from-to line from the property to the hospital, routing those into the shortest path finder and saying, hey, find me the shortest path. Well, in some respects, every one of these could be done separately. So I'll just show how I would start to do this. I would have to divide these properties into different groups, and so this is sort of the trick, one of the tricks of multiprocessing. And to do that, I'd throw down a modulo counter, and let's just say I would do it with 3 groups. I'm going to make 3 different groups, whoops, and I should name the output underscore group. So I've got 3 groups going. Now I would tell the shortest path finder, hey, group this thing by group. That's fantastic. Crank her to, let's go extreme. Just for, well, that probably would be a bad choice unless I have lots of memory. Maybe moderate would be good. And now I'd be good, except you'd say to me, well, Dale, you divided all you got to be careful when you're doing this when there's multiple input ports. If I was dissolving, I'd be done. But here I got 2 input ports. I've made a nice group on the guys that I know that I'm interested in that have to be different, the from-to nodes. But what about the network? It doesn't have a group. And so here, I sadly enough have to clone the network. And I'm going to make 3 copies, 1 for every group, and I'll name them 0, 1, 2, 3 will go into this as well, and that would do the trick. So just to prove that that works, and I'll just open up my other example here. And this is exactly that. I've named it a bit better, and this will be the one you get. Divide into groups as a modulo counter, copy per group. And what I did here, just to make sure I don't goof up, is I assigned a private parameter to both of these things so that my number of groups stays in sync. And now I'll go ahead and run this, and nothing's quite as exciting as watching a parallel processing thing run. You can see all the different log pieces rolling by with their prefix. Here I'm paying a bit of a price because I'm sending 17,000 features times 3 into every group. And I'm only doing a measly 167 or so bits of actual work in every group. Now if I would do every address in Vancouver, I would see even a more dramatic speed up than what I'm going to see here. This thing is going to end up taking about 50 seconds down from 136, and that's even with the huge overhead I've got of all those clones. So that's that one, and probably the other thing I was going to show, which I won't get into, but this is an example of a tax lot thing where I might want to do a dissolve. So I could do a dissolver here, and then I would do something ahead of time to assign. I wouldn't actually do, whoops, okay, there must come my shortest paths are done. And so let's just turn off the network. Yeah, these are all the shortest paths for these people that need to get to VGH. And so let me just flip back. And it took 59 seconds because I was fiddling around, but still down from 1:36, worth it for this particular case. Hopping back to my dissolve case, I'd have to figure out a clever way to partition the input, and this is not a clever way. By assigning a number from 1 to 3 to everything coming in is probably not a good thing because I would get random things. I would rather basically do a feature count and do a divide by 1,000 or something to get me different groups. Then dissolve by those groups. That would give me 20 things out. And then lastly, I would do one more dissolver at the very end to catch and dissolve that. And that would be a much improved thing. And I will actually make that example to give to Ken to include in the output or in the slides. So I think I'm going to say that my time is up, Ken, and I'm going to give it back to you to wrap her up.
All right. Thanks very much, Dale. Am I live? Are you guys hearing me?
You are live, Ken.
Yep. Okay, great stuff. Well, I want to thank all three of our panelists because that was really fantastic material crammed into a very short amount of time. As I said before, clearly this is a topic that we could say much more on, and we hopefully will say more on. I think part of the plan is to include performance-related topics in all of our webinars going forward, but hopefully we'll have another performance webinar on its own as well. All of our webinars are recorded, and this one is being recorded right now, so you can see the webinar. It's accessible at safe.com, where there's a little short link to it there. Personally, I go back to some of our archived webinars fairly often to get technical information. So if you missed something here, go ahead to the archive, and the workspace examples will all be there as well. So,
and as we're mentioning, Ken, we're also chopping these up in little pieces. So if you'd like to hear Mark Ireland's smooth as silk voice over and over again, you can just do that.
Yeah. We always have a draw for free online FME training that we offer to webinar participants. I'll throw up a poll at the end just to see who's interested in that. So that will be coming along when we wrap up. But thank you very much, everyone that attended, for joining. As I mentioned, we had panelists from 3 different countries, and we had attendees from many more countries. So thanks very much. I know it's not the perfect time of day for all of you, so we appreciate you joining us. For more information, you can contact your Safe Software partners. We have resellers all over the world. Dave is with one of our partners, One Spatial in the UK and Australia. Safe Sales, there's the email address there. FMEpedia was mentioned numerous times in this presentation. We've obviously got a lot of resources available on this topic in FMEpedia, so please have a look at FMEpedia. That's our knowledge base, and also our answers community is there. And there's also Safe Support available at safe.com support. So I've put all of our Twitter handles at the end. Thanks very much once again, panelists, and thank you, attendees, for joining, and we'll see you at the next webinar.
Thanks, Ken. Thanks, everybody.
Thank you all.
Bye-bye.